Hello, I welcome you all. The problem reads determine the maximum constant speed at which a 2 megagram car can travel over the crest of the hill at air without leaving the surface of the road. Neglect the size of the car in the calculation. So we are dealing with constant speed here, so we don't expect any acceleration, tangential acceleration. Let's draw the free body diagram. So let's say we have the weight. We have the weight of the car. Maybe let's move this car a little bit somewhere there, like so. So let's say we have the weight of the car and we're going through there like this. Okay, and let's say we have the normal force like so, and we have this coordinate, which is our coordinate A, and then this one as our coordinate T. So this is T, this is N, this is W, which is the weight, and this mg, and this is N. All right, so of course we do have three conditions. We have N less than 0, N less than 0. In this particular case, we are saying the car is not in contact with the surface. This is where the car is really speeding, and all it does, it just almost flies off at this point. Okay, then we do have N. When N is equal to 0, the car is at the verge of losing contact with the surface. Okay, then we do have N greater than 0. Okay, greater than 0. This is where the car is in contact with the surface. All right, so we have these three conditions, and for us to find the maximum, we need to use this particular condition here. So let's apply the equations of our motion, and let's say our kinetic diagram of motion is denoted as shown. So say summation of forces in the n direction going down in our reference, and this is just equal to MAN, where our AN is just equal to V squared divided by rho. And then we're going to use this to calculate our rho. Our rho, using the equation of the radius of curvature, is just equal to 1 plus y prime squared, and then everything to the power 3 over 2 or 1.5, then divided by y double prime. So we know that y is just equal to 20, okay, 1 minus x squared divided by 10,000. Therefore, y prime will just be equal to y prime is equal to 20 by minus 2x divided by 10,000. This just becomes a minus 4x divided by 1,000, right? And then we have y double prime, which is just equal to minus 4 over 1000. Okay, this also is just equal to minus x divided by 4 there. This is 2, when the 2, so this just becomes a 250. This is also just equal to minus 1 divided by 250. Alright, with this, alright, so of course this point here is our A. This point here is our A, right? In fact, there it is, this is A. Right. Okay. So now let's find the value of A prime at A. So at A, this is our reference point. At A, x is equal to 0. Okay. Therefore, y prime at x equal to 0 just gives us 0, right? This one here, y prime, this one, right? So having done that, then we can say our rho therefore will just be equal to 1 plus 0. Okay, then this to the power 1.5 divided by minus 1 divided by 250. This is modulus or absolute value. Okay, and this just gives us a 250, right? So with that, we can now use this equation. And say we have what do we have? We have W minus N equal to mv squared divided by rho. But we know that N itself is equal to 0. That's what we said, right? So this is going to be equal to 0. Okay. So if that is the case, then we can simply say our W, which is just mg, will be equal to mv squared divided by rho. So we can cancel out m and m like so, and what we remain with is just v squared will be equal to rho g. Okay, so let's square this both sides. We square this both sides, and once we do so, then we find that our v will be equal to our rho is 250 times our g, which is 9.81, right? Square root of this, then we have our v is just going to be equal to, this is v max. Our v max will be equal to let's work it out, 250 by 9.81 square root over, this gives us a 49.52 meters per second. So this is the maximum speed that the car can drive over the hill without losing contact. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next stream.